Consider a 100 ohm resistor and a 300 ohm resistor wired in parallel with a 12 volt cell. Calculate the power drawn by these resistors. Compare this to the power drawn by the same two resistors when wired in series. All right. So first of all, we need to remember, what is power? How do we calculate power? Not IR, that's V. IV. Power is voltage times current. Okay? So let's look at our two circuits. So first we have a 12 volt cell, we have a 300 ohm resistor, and we have a, well, pretend that joins up, 100 and 300. Okay. What's the first thing we're going to do here? Sorry? Someone said it and they were right. Good. Find the equivalent resistance, our total resistance. So 1 on RT for a parallel is 1 on 100 plus 1 on 300, which is 1 on 300. So our equivalent resistance, oops, is 75 ohms. All right, passes the common sense test. It's less than both of the other ones. So our equivalent resistance here is 75 ohms. So now in this circuit we can find our current. V equals IR, so I equals V on R. Our voltage is 12. Our resistance is 75. So our current is going to be 0.16. Oops. Ugh. 0.16 amps. Okay, so we've got our current. So now we can work out well, we know our current and we know the voltage in both of those, because the voltage in both of those is the same. It's 12 volts. Okay? In a parallel circuit, the voltage in each resistor is the same. Okay? Or, as long as they're, our coulombs are either going this way or that way, but either way they are giving all of their energy to one resistor. Okay? So, in the 100 ohm resistor, we have 12 volts. In the 300 ohm resistor, we also have 12 volts. All right. So now we need to work out the current going through each resistor. Okay, so in the 100 ohm resistor, let's call this R1 and R2. In the 100 ohm resistor, R1, our current is equal to V on R, which is equal to 12 on 100. 0.12 amps. And so just looking at our total current, we would expect this one to be 0.04 amps, right? Because both of those added up will give us our total current. So let's see. R2, our current is going to be equal to 12 over 300. And look at that, 0.04 amps. So we have the current in each resistor, and we have the voltage in each resistor, so now we can work out the power in each resistor. All right, so power in R1, whoops, the power in R1 is just equal to current times voltage, so our current is 0.12 multiplied by 12, 1.44. What's the unit for power? Watts. Good. So R1 is using 1.44 watts. Our R2, 0.04 multiplied by 12. 0.48 watts. Okay, so that's the amount of power each resistor is drawing. Okay, so now we need to compare this to the amount of power they draw if they are in series. So let's have a look. So we have our 12-volt battery there, 100, 300, R2, R1. Okay, so our total current. So remember, in series, to find the total equivalent resistance, I'll put this down, we just add them together. So our total resistance is 400 ohms. The current in our circuit is going to be V on R, so 12 on 400, which should be 0.03. So 0.03 amps. All right. It's actually a good problem. There's a lot to it. All right, so next, we need to work out the voltage going through each resistor. Because remember, our voltage is different in each resistor in a series circuit. So our voltage for R1 is equal to IR. We know our current, because our current is the same the whole way through. So we have 3 volts going through R1. Now looking at our total voltage is 12, we would expect 9 volts to be going through R2. So let's have a look. VR2 is equal to 0.03 multiplied by 300, and sure enough, that's 9 volts. Okay, so we have our voltage and our current going through each resistor, so we can work out our powers. Power through resistor 1. Okay, so resistor 1 is 0.03 amps multiplied by 3 volts is 0.09 watts. And through R2, we have 0.03 amps multiplied by 9 volts, which is 0.0, oh, no, it's not, 0.27 watts. Okay, so looking at those numbers, so we are finished now. That's good. We got to the end of it. Those are our powers for the 2 light globes in parallel. These are our powers if our light globes are in series. So in series, they draw a lot less power. Okay? So this is the benefit to doing things in series. They do draw less power. But the benefit to doing them in parallel is that each globe is going to use the full amount of voltage. Okay? They're both going to be as bright as they possibly can, whereas in series, they have to split the voltage. So they're going to be a little bit dimmer. Okay? So that's why. So we read earlier in a parallel circuit that a battery will run down faster. That's why. Because our light globes use much more power because they are using all of the voltage each. Okay? All right.